Angles. In this lesson, Larry Williams will share some important information about adjacent, complementary, and supplementary angles. Then I will share some very important information about these angles.
Adjacent angles are two angles which share a common vertex and a common side. Angle BAC and angle CAD are adjacent angles. Angle BAC and angle CAD are adjacent angles. They are adjacent angles because they share a common side, line segment AC, and a common vertex at angle A. Complementary angles are two angles whose sum equals 90 degrees. When complementary angles are placed together, they make a right angle. These angles are complementary angles. Complementary angles are two angles whose angle sum is 90 degrees. This angle is 30 degrees. This angle is 60 degrees. These two angles added together is equal to 90 degrees. When one angle of a complementary angle is known, then the other angle can be calculated, since you know that together they equal 90 degrees. When one angle of a complementary angle is known, then the other angle can be calculated. Angle CAD is equal to 36 degrees. Therefore, we define the angle of BAC. BAC can be calculated by subtracting 90 minus 36. 90 minus 36 is equal to 54 degrees. Therefore, angle BAC is equal to 54 degrees. 54 degrees plus 36 degrees is equal to 90 degrees. Supplementary angles are two angles whose sum equals 180 degrees. When supplementary angles are placed together, they make a straight line. When one angle of a supplementary angle is known, then the other angle can be found, since you know that together they equal 180 degrees. Supplementary angles are two angles whose sum equals 180 degrees. This angle is 120 degrees. This angle we know has to be 60 degrees because supplementary angles have to equal 180 degrees. 120 plus 60 equals 180.
The information about complementary and supplementary angles is extremely important when working with angles. I want to stress this. Whenever there is a 90-degree angle and there is any line bisecting this at the vertex, and you know one angle, you can always figure out the other angle. For instance, if this angle is 38 degrees, you can always figure out this angle because this is 90-degree angle. It's a right triangle. So it's 90 degrees minus 38, and that equals 52 degrees. So this then is 52 degrees. Now this is very simple to learn this here. But you know, in the workplace, we don't get little simple diagrams like this, but we use the rules for these angles, for complementary and supplementary angles. We get thousands of prints. These are two boxes that we have, and we got more in our shop. And you can see they're just filled. And we save these. These jobs have been done already. But we have to use these skills that you're learning now. And we can't go over the thousands of applications for these angles, but these rules stay the same. So learning these principles are critical in the workplace. Besides writing books, I'm also the president and owner of Reliable EDM, where we specialize in doing electrical discharge machining. I'm standing in front of one of our wire EDM machines. And with the means of a wire, we can cut out all kinds of configurations, including angles. We can cut up to 45 degrees. The computer programs the design, and then the machine cuts it out. And it works through electrical discharge machining. And as you can see over here, here's the wire going through the part, and the machine is now cutting apart. and it cuts with accuracy to plus or minus 1/10,000th. That's less than 1/20th the thickness of your hair. Now here are some angle pieces. This is an extrusion mold. Notice it's thick on the bottom and thin on this side. And plastic gets extruded and out comes this shape. There's another shape that was made. Notice it's thick on the bottom. Here's a part that has two angles. This was first cut, then we cut the second one out, and that's the shape that we have. Here's a part that was cut 45 degrees. There's the bottom, and there's the top. Here's a part that we EDM'd. This is two pieces, but we had to EDM that out of a part. And I have this on a diagram up here, and this is 10 degrees. What is the angle between these two angles? Let me draw that over here. You have this and this, and the part's down like this here. And from here to here, that's 10 degrees. And we can also draw a line across that makes this also 10 degrees. And since they're both equal, this is also 10 degrees. And you know a straight line is 180 degrees. And this is 10. Plus 10 is 20. And so that will leave it 160 degrees. So this angle is 160 degrees. And as you can see, there's many applications for working with angles. This is just one little example, but in many different fields and applications, one needs to know how to figure out angles.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.